Alright, number 12, this will be our last one here. We have a polynomial inequality, and we have two parts. Step 1, we want to set one side equal to 0 and list the interval endpoints and only points at which the non-zero expression can change the sign. Okay, so the only points at which the non-zero expression can change signs. Okay. So we're going to set this equal to 0 and we're going to solve. 2x squared less than or equal to negative 3x plus 5. Alright, we're going to move everything over and set it equal to 0. So we have 2x squared, it'll be plus 3x, and then minus 5, less than or equal to 0. We will see if this will factor. So 2 times 5 gives us 10. Factors of 10 are 1 and 10, 2 and 5. We want to subtract to get 3, and we get that with 2 and 5. Alright, so we have a number out front this time. So in order to avoid playing the guessing game, not sure which one is 2, not sure which one is 1, I'll put a 2 in both. This is incorrect. I'm putting a little x out there to remind myself I have to fix that later. Split up the x at the back, 2 and 5. And left to right, first sign is the bigger number, so 5 is positive. Second sign is negative, which tells me they're different. So if this is positive, this is different, it has to be negative. And then to fix this, I'm going to try to reduce these two numbers and just get rid of it. So 2 and 2 are both divided by 2, or divisible by 2. So divide them both by 2, we get x minus 1. And then these will not reduce. And that is usually the case. And that should fix it. So at this point, if you multiply this back together, you should get what you started with, less than or equal to 0. Now, we are going to set both of these equal to 0 and get some numbers. So we get x equals 1, and then here, what I was saying, if you have a number out front, let's actually work this one. 2x plus 5, we'll just say less than or equal to 0. So you subtract 5, so you get 2x less than or equal to negative 5, divide by 2. And you get x less than or equal to negative 5 over 2. Alright, so we're going to have to figure out which part is correct. So we got two numbers. Should say less than or equal to. When we move that over. So we got two numbers on our number line. We have negative 5 over 2, and then we have a positive 1. And usually with less than or equal to, we're in between these two. Greater than, you would be on the outside, so this should be our interval. But I think the first step just wants those numbers. So we're going to say negative 5 over 2, comma 1. Make sure. So it says set one side equal to 0 and list the interval endpoints. Alright, now it says test the interval, find out which one satisfy the inequality. Okay, so again, less than or equal to. I really could have just set the problem up like so and just put your endpoints. And then when you have greater than, you would be having x is less than some number, or x is greater than. You would have the outsides. But less than will be in between. So you can pick a number in between here, 0, and test it out. That's the easiest thing to do. So if I put 0 in here or in my original equation, 0 here, 0 here. This will give me 0. This will give me 0 plus 5, which is 5. So 0 less than or equal to 5. That is true. So that means right here in the middle. And if I pick some negative and positive, I will get false. You won't see that. So this part is true. These parts will come out to be false. Okay, so the interval in square bracket will be negative 5 over 2 to 1.